All right, so draw an upright cone in the margin right here. I'm gonna do that myself for the video. Take two, can't use names. That was fast. So we are drawing an upright cone in the margin. No longer imagination. Now, a certain student in here built a cone with Play-Doh. Do you have Play-Doh on your test? Actually, you do. It's right here.
Oh.
You just gotta have the courage to come up and get one. Okay, so you no longer have to imagine. You got it right here in this box. And you got the giant playing cards to represent a plane. Now, a certain student in here built a beautiful cone. I saw it a second ago. Now, same person, blue hooded sweatshirt. Can you read A for us? A vertical plane, excuse me, TA, teaching assistant in the back. Could you click on my slides? Thank you. So, a vertical plane not passing through the cone's topmost point. This is the cone's topmost point, right here. Double click, and then unify stick. There it is. Beautiful. Thank you. That means it's going to be like going just to the side of the apex, topmost point. So on the video, we're gonna put our giant playing card like through here. Now, person with the cone with Play-Doh, I want you to make that cut. So do something either on the right or left, like so. Nice. In case you need a visual, they are doing it right now. Hold up the inside. Show it to the whole class. Can everybody see that? Now you don't imagine, you're literally looking at it. So we have to sketch the cross section. Toss me one of those. I'm gonna try to catch it. Nice toss. There it is. What is that shape? Anybody? Right here. Yep. Okay. Coming back at you. Ready? Put it back together. Okay. That one is around here. Nice work. Great job participating too. All right, next one. Try. You got to go fast, unfortunately. But it's pretty easy for B. Now, blue hooded sweatshirt, read B. Horizontal plane. So rather than this vertical plane right here, new one. They want this one. So try to do that. Try. Nicely done. Extra points. With a little help from some friends. Hold up what you got. Cool. Hold it up. Everybody see that? What are we gonna sketch? Yep. Can I see that? Can I see that? Can I see that, Dave? Excuse me. Can I see it? Toss it to me. Toss it to me. Oh yeah. Oh, it's okay. Good job. Circle. Coming back at you. Circle. Nice. All right. Next one. Tricky. goes with the Play-Doh. Blue hooded sweatshirt, could you read C for us? Read C for us. Go. The reason I always ask students to read the directions is because you never want to say anything the student can say. Then you lose power of getting the crowd. All right, I'm seeing a lot of hands. Let's say it all in unison, really loud for the camera.
Oval.
Oval.
Boom. Well done. So hard not to say your names. That's it. Irma. Can you scroll down for me? Okay, blue hooded sweatshirt. You read numero dos. Starts with here. All right, here are two solids. We got a right prism with a square base, and we got a pyramid with a rectangular base. The action is to draw the cross section. So draw the cross section. That's what you have to do. Resulting from the intersection of the solid and the plane. Now again, intersection, solid, and a plane. Can I get that giant plane start again? Actually, hang on to it. Just take good care of it, okay?
Okay.
Don't bend it or nothing. All right. So, when you see something asking for an intersection of a solid with the plane, go get a giant, bless you, go get a giant playing card and a thing of Play-Doh if you're stuck. So, we are going to, and maybe you can do it without it, like right now. Here we go. We're going to answer these two questions. Cross section resulting from the intersection of the solid and the plane. So we're just like going right through this one. A horizontal plane intersecting the prism halfway up its height. Remember what the base is. Remember what you got to do. You got to draw the cross section. First ask yourself, what is the cross section? Answer it. Go for it. Yep. Now you draw it. Technically, if we're being straight up honest, is what I drew a square yet? No, it's not a square until I label it correctly. Boom, 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 boom. Gotta label it. If you don't label it, it's just a box. Now it's labeled, we're good. Question or comment? What's that for? You want to do number 2? Okay. Go ahead and read B. Thanks. All right, so this one, we got to go straight through the apex. So we got to go through the apex. Now, if you can imagine what it's going to be, that'll save you time building the Play-Doh. Because building the Play-Doh takes time, and you want to save as much time as possible. So your imagination might help you even more on this one. What is the shape for B? Yep. Yep. So there it is. Okay, teaching assistant. Can you go to the next one? Teaching assistant. Help me. Go to the next one. It's okay. Working. If you want to be a TA next year, you get to like work too while you get to knock out homework from other classes. And I need so many TAs. I need 10 TAs next year. So if you have a chance to be a TA, please do. I need all the help I can get. I got 140 students. It's a tall task. All right. Number 4, direction read. Actually, I'm going to go to the person, nudge them, okay, next to you. Nudge them next to you. Cool. I'm going to have you read number 4 right here, starting with imagine. All the way from imagine to cone. As loud as you can.
Imagine an upright cone with its face resting on the horizontal base. Match each plane with the images of the cross-section formed by intersecting the plane with the cone.
Nice. That was such a loud direction read. I appreciate it. That was a good job. All right, so let's see. Imagine. How about instead of imagining, we draw. So right now, in the margin, like I'm doing, draw yourself in a cone and make sure it's like a normal upright cone. So you're drawing a cone. Take your time, draw a cone. That way, instead of imagining, you got a visual. Y'all are doing great, by the way. It's so hard to video live. Add a little oomph. Y'all are just drawing a cone like I am right now. Okay, so here is an upright cone. Don't lose me. All right, first one. I'm seeing a triangle. Okay. Figure 1's a triangle. Can you nudge that person? Thanks. Horizontal cut. Let's talk about that. I'm going to show the class this figure. I'm going to do a horizontal cut of that cone. Horizontal. Okay? See that cone? We're going to go straight across. Cool? We're going to go straight across that cone. What's the horizontal cross section? Yep. Circle. So this one's A. Nice. Now let's talk about vertical through the topmost point. What's that one? So vertical through the cone's topmost point, right over here. Yeah, right here. That's B. And diagonal is going to be C. Which is oval. Yep. And then last but not least, just connect the dots. Figure 1 is B. Horizontal is figure 2. This is like some of the most maddening part. Is like doing the matching. Like you figured out the answers, now you gotta match them. Blue hooded sweatshirt, you're gonna read the directions coming up. Nudge. Thanks. Alright, teaching assistant. Scroll down. Thank you so much. You're saving me so much time. All right, 9.1. I think it's almost the same direction as before. I love the seriousness of this class right now, by the way. Go for it. Easy. Here are two solids. Nicely done. Up to 5. Cool. All right. We're going to do this again. 1, 2, 3, 4. The name, formula for volume, the base shape, and we're going to compute these. Now, we're going to answer the questions on this one. Answer 1 and 2. All right, so we're going to do 4 questions. So, a quick reminder. Catch up if you're not there. We're doing the same but different. I'm going to ask you to name the shape. So, name the shape. I'm going to ask you for the volume formula. I'm going to ask you for the base. And we're going to answer 1 and 2. This will give you a lot of practice and a lot of chance for points. So, cool. First one. What do we got? Name of shape. Yeah. Cylinder. I'm going to do it from right here. So, cylinder, number 1. Cool. And coming back to that same person. What's the volume formula? Pi r squared times height. Back to that same person. What's the area, or what's the shape of the base? Circle. And then let's answer number 1. What information would you need to calculate the volume of that cylinder? You need the bases. Yep. You need the bases area. To find the bases area, what would you need? The radius. Cool. And then what other thing do you need? It's in the formula that you just told me. Height. Nice. Cool. Nice work. So for this one, you need the radius and the height. And how many questions was that? 4? 4? 1, 2, 3, 4. All right, next person. Nice, waking up. I love it. Name. Ready? What's the name of that thing? Okay. Volume formula? L times W times height. Great job. What's the shape of the base? Okay. And let's answer 1 and 2. What do you need to solve that one? What info do you need to find the volume? Yep. Length, width, height. Beautiful. That's 4. Okay. Now, question 2. Blue hooded sweatshirt. You ready? All right. You ready? Number 2. Can you read the directions? Nudge. Quick nudge. Right here. Ready? Yeah. Read number 2.
What is the same and different about how you will find the volume for each solid?
So they said, what is the same and different? So let's talk about what's the same. Now, universally, volume formula for any solid that we've been talking about that does not have an apex, what do we always go with? Yeah, base times height. So what's the same about both of these is that you're going to go base times height. All right, brown hooded sweatshirt. Here we go. Quick nudge. Quick nudge. Brown hooded sweatshirt. All right, there you are. All right. Back over here. What's different?
What's different is one uses radius and the other one is length times width.
Yes. One is pi r squared times height. The other is length times width times height. So that's a good answer for same and different. And they said same and different. So for this one, LWH, for this one, they're both base times height. That's what's the same. They're different. One is pi r squared times height versus the other is length width times height. Great job. Great job. Great job. All right, next question. Teaching assistant, please. Teaching assistant. Yeah. Okay, we go right here. Hey, you read the directions? Yeah, so suppose each two-dimensional figure, these are the 2D figures, is rotated around the vertical axis shown. Each small square represents 1 square centimeter. So each small square represents 1 square centimeter. Let's go ahead and write in the lengths now that you know that. You're gonna need the height, the radius. You're gonna need the height of the other one too. Now we're gonna start filling these in. What is this measurement? No, there it is. Who said it? Cool. 3. Where's that one? 3. Nice. What is this one? 5. Yup. Cool. Nice job. All right. This is 2. Right here. Nice. Label those. That's a good first step. Now, we're going back to this concept right here. Right? Going back to this concept right here. RM. Dutch. I'm rotating that 2D figure. What's the 3D shape that appears? Cylinder. Nice. So we're rotating this puppy. We're gonna get a bunch of cylinders. Now, first one is 1 cylinder on top of the other, which is tricky, but you can do it. And now that you have your measurements, you can start to think about how you're going to compute this. Because like a few people said, that's 5, which is going to be your radius. There's the top. This one's going to be like so. You're going to start to see something that resembles. Does anyone know the example I'm thinking of?
Wedding cake.
Yes! Wedding cake. So something that resembles a wedding cake, which is 2 cylinders stacked on top of each other. The bigger one on the bottom. Bigger on bottom. Wedding cake. Nice. Now, let's find this solid's volume. Remember, you have a radius of 5 and a height of 3, and we're talking on the bottom. So Nike hoodie. Down to do the bottom cylinder. This one. Down to do it. Okay. Write out the formula for this one, which is pi r squared times height. Okay. What's our radius? 5. So it's going to be pi 5 squared. What's our height? Just the bottom. 3. So radius is 5, height is 3. So we go pi 5 squared times 3. Now, what is 5 squared? 25. What's 25 times 3? Yep. So the volume for the bottom is 75 pi. Now, your neighbor, this way. Okay? Let's do the top. You ready? Go ahead and write out the formula, okay? Just do it with me. You're going to watch the video later and be like, crazy, we did that live. All right, so what's the volume formula of a cylinder? It's pi r squared times height, right? So write that down. V equals pi r squared times height. Now coming back to you, you ready? What's the R? Look again. 2, yep. Pi 2 squared, what's the height? One more time, just the top. 3, yep. Okay, so you got pi times 2 squared times 3. What's 2 squared? It's okay. 4, what's 4 times 3? 12, and then you can't forget that pi. So up top you got 12 pi. On the bottom you got 75 pi, right? Right? Still with me over here? No? 12 pi plus 75 pi is?
87 pi.
Yep, 87 pi. Nicely done. So your volume of that wedding cake is 87 pi centimeters to the 3rd power. Whew. It's hard to write neat while I'm filming and teaching. But here are some points. 1, 2, 3. 1, 2. 1, 2, 3. Nicely done. All right, next one's tricky. Next one's really, really tricky. I'm gonna do it on here first, and then I'm gonna do it on the board. You are going to have a cylinder, but it's gonna look a little different. There's gonna be a huge hollow point in the middle. So you're gonna have this big hollow portion. Your radius of the big one's gonna be 5. The radius of the hollow portion will be 3. Now, for you in class, it's gonna look like this. It's gonna look like this, okay? For you on the video, it's gonna look like toilet paper. All right, let's draw it. It'll help. 5. So it's gonna be like this shape. And the whole middle part shaded in to represent the hollow portion. So we got a toilet paper roll. All right, over here, you ready? We have to do the big cylinder minus
Small.
the small. Yeah, and the small one is the hollow part. So let's start with the big cylinder. What's the formula for a cylinder?
Pi r squared times height.
Pi r squared times height. Okay, so let's start with the big one. It's gonna be pi. What's your radius?
6. Wait, 2. Oh, the big one is 5, right?
Yep. Pi 5 squared. What's your height?
6.
Okay, so we got that. Now we're gonna do the small one. What's the formula for a cylinder?
Pi r squared times height.
Pi r squared times height. Cool. What's the radius of the hollow portion?
2.
Look again.
Oh, oh, 4.
Nope. 3.
3.
It's okay. No sweat, no sweat. So you got it. It's pi 5 squared times 6 minus pi 3 squared times 6. So check that out again. Radius is 5. Pi 5 squared, height is 6, minus the hollow portion, just the hollow portion, which is right there. That radius is 3. So minus pi 3 squared. Teaching assistant, need you. Thank you, by the way. I know you're working on something, and that's okay. Thanks for your help. Appreciate it. Trying to do a lot here today. All right, cool. So here we go. Same person over here.
Yeah.
Who don't say it. Never mind. Never mind. 1, 2, 3. Let's go to. Yep. Here we go. Take us to the finish line. This will be. Let's just work up here. Sorry. Pi. What's 5 squared?
High school?
25, right?
Oh, you said 5.
Sorry. Times 6, right? So that's gonna be. Yep. All right. And we're gonna subtract. What's 3 squared? Yep. And what's 9 times 6? Yep. So 150 pi minus 54 pi will equal. Yep. And we're in centimeters, so you gotta go cm cubed. So this one is 150 pi minus 54 pi, which equals 96 pi. And then you gotta get this cubic centimeters. Cool. It's 12:05. We got 5 minutes. Let's see what else we got. I am going to cut it right there and cut the video. And then, let me see here. Yeah, I think I'm gonna pick up with period 5 for this portion. All right, so there's gonna be 3 videos total. Cutting the video now.